So use the given information to find the p-value. Use a 0.05 significance level and state the conclusion about the null hypothesis, either rejected or failed to reject. The test statistic in a right-tail test is 0.52. Okay, so this is a right-tail test, and the test statistic is 0.52. Okay, just by looking at that number, 0.52, do you think that is an unusual value or not?
It's more than half on the right side.
Okay, so yeah, it's a little more than the midpoint. Is this an unusual value? Is z-score of 0.52, is that unusual or not? Okay, so, but that's p-value, right? We're looking simply, remember, what makes a z-score, usual or unusual? Yes, Adam?
Less than a z-score of 2, so it would be usual.
Yes, it's usual, just normal sample fluctuation. You're just right, kind of right in the middle, right where you're supposed to be. So we already know that we're gonna, what? Reject or fail to reject? We're gonna fail to reject. But we still want to find the area. So to find the area to the right of this test statistic, we use what? Inverse norm is to find critical values. We're not finding critical values. We actually have a z-score given. Normal CDF. So it's really important to know which one to use for which. So normal CDF, our area starts at 0.52. It goes up to a very large number. So we can put, 100,000, 999,000, or we can just actually enter in like E99, which is infinity on the calculator. So let's see. No. The lower is 0.52. This is where my area starts, and it goes up to positive infinity. So normal CDF is under the distribution, so that's second vars. We are going to start at 0.52. We're going to go up to E99. And if I haven't shown you guys how to get to that, it's actually the EE button in blue right above the comma. So it's second, E, and then 99. That's going to put it to infinity. Or as I stated before, you can just put a large number. 100,000, 900,000, 1 million, something big enough. Okay, our p-value is 0.3015. P-value is rounded to 4 decimals. Okay, we don't have to double it because it's just a one-tail test. So 0.3015, this p-value is greater than our alpha, and therefore we're going to fail to reject. So the correct answer would be C. Okay, so just remember when it's like somewhere in the middle, just normal sample fluctuation, you're going to fail to reject. If it's in the tails, that's when we reject. Yes, Kyra?
So when you add a z-score, that makes it normal to CDF?
When you're trying to find the p-value given a z-score, you're going to use the normal CDF. Now, most of the times, we can do an entire hypothesis test, right? So we would just do the one proportion z-test, and that's going to give us the test statistic and the p-value. Then we use the inverse norm to find the critical value. This question is phrased a little different because we already have the test statistic, and we don't have all the information to do an entire test, so it's slightly different. So let's look at number 13 together as well. This time we have a left tail test. So that means we're going to put the area, we're going to look at area to the left. Our test statistic is negative 2.05. Negative 2.05, that's right on the borderline. That may or may not be unusual depending on our alpha. So we're going to find the area to the left of it because in a left tail test the p-value is the area to the left. Using the normal CDF, what do we enter as the lower value? Yeah, negative infinity or negative 9999 or negative 1 million. What's our upper value? Right, and then it's standard normal, so let's look at that. over here under the distributions, normal CDF, negative E99, positive, actually negative 2.05. And so we have an area to the left of 0.0202. 0202. That's our p-value. What's our conclusion? This p-value is less than or equal to alpha. When the p is low, we're going to reject the null. So 0.02 and reject the null hypothesis. And now we have just one more scenario, and this is going to be a two-tailed test. So it says with H1, P is not equal to 0.501. The test statistic is Z equal to 2.83. Okay, so just by looking at the alternate hypothesis, this is going to tell us that it's two-tailed because there's a not equal symbol. So in a two-tailed test, our test statistic can fall either on the right or on the left. In our case, it's on the left, so we're going to simply put 2.83 in here. We now calculate the area to the right, but since it's two-tailed, we're actually going to double that area. So kind of put a pretend left tail with the same area in there over on the left. So this is why we have to double. What's the area to the right of this value? How do we find it?
Normal CDF, our lower limit is 2.83, upper limit is a very large number, and 0.1.
Okay. And then we're going to actually do 2 times that number. All right, so we can even do 2 times the normal CDF over here, going from 2.83 up to E99. And so that is 2 times 0.0023, which is 0.0046. It's really rounded up to 47, but we'll write it as. That's what I got over here, 0.0047. Okay, so is this P, how does it compare with alpha?
It's less than 0.05.
Yeah.
Okay, so the P is low, we are gonna reject. Okay, so 0.0046 and then reject the null. Our answer would be C.